All right, number two. What is the magnitude of the vertical component of the velocity of the plane in number one? Referring to what we just did. What is the magnitude of the vertical component? So what do I not have to include in my final response? Don't have to include direction, right? I just need a number. So we still know that the velocity of the plane is 105 kilometers per hour, and the angle to the ground is 25 degrees. If you don't believe me, you can go back and check this this problem that we just did. Draw my triangle. So I know that I have 105 kilometers per hour. Here is the horizontal component of the velocity, and here is the vertical component of the velocity. Now remember, I am looking at this problem from the perspective of this angle. And again, so, I'm looking for the vertical component, so that's going to be v sub y. So this is the opposite side, right? The opposite side relative to this angle. So opposite side is going to be sine, and we know that the sine of any angle is the opposite side divided by the hypotenuse. Whoa, that was a bad y. Oh, goodness. And so if I'm going to solve for the opposite side, which would be the vertical component of the velocity, I'm going to need to algebraically rearrange this to look like opposite side is equal to the hypotenuse times the sine of the angle. Opposite. The hypotenuse is 105 kilometers per hour. And then sine of 25 degrees. And this ends up being 44 kilometers per hour. Now, between numbers 1 and 2, we've actually completed this triangle. We started just with the knowledge of the hypotenuse, and then we used cosine and sine to figure out the horizontal and the vertical components. If, for some reason, you forgot that the resultant, the actual velocity, was 105 kilometers per hour, you could use the Pythagorean theorem to figure that out again. Once you have the two sides of the triangle, right, you can use the Pythagorean theorem.